Have you ever dreamed of hopping in a DeLorean and zipping back to the 80s? Or maybe forward to see what the future holds? Time travel is one of science fiction's most delicious concepts, but what does actual science have to say about it? Today, we're diving into 10 mind-blowing facts about time travel that might just change the way you look at the clock. First up, did you know you're time traveling right now? No more, seriously, you're moving forward in time at a rate of 1 second per second. But here's the kicker, according to Einstein's theory of relativity, the faster you move through space, the slower you move through time relative to a stationary observer. This isn't just a theory, it's a proven phenomenon called time dilation. If you were on a spaceship traveling near the speed of light, you would age much slower than everyone but on us. So, traveling to the future is, in a way, scientifically possible. You just need a really fast ride. Our second fact takes this a step further. It's not just speed that bends time, gravity does too. Einstein's general relativity tells us that massive objects, like planets and black holes, create a gravitational well that warps the fabric of space-time. The stronger the gravity, the slower time passes. This effect is real and immeasurable. GPS satellites, for example, have to constantly adjust their internal clocks. Because they are further from Earth's gravitational pull and moving very fast, their clocks run slightly faster than ours. Without these tiny corrections, your GPS would send you miles off course within a single day. So, want to time travel to the future? Just hang out near a black hole, but maybe not too close. Fact number 3, what about traveling to the past? This is where things get really tricky. While the laws of physics don't explicitly forbid it, traveling backward in time opens up a whole can of worms, or more accurately, a can of paradoxes. The most famous is the grandfather paradox. Imagine you travel back in time and you prevent your grandparents from meeting. If they never meet, you are never born. But if you were never born, who went back in time to stop them? It's a logical loop that has stumped physicists and philosophers for decades. This brings us to our fourth point. A potential solution to the grandfather paradox is the multiverse theory, or the many-worlds interpretation. This idea suggests that for every possible outcome of an event, a separate, parallel universe is created. So, if you went back and stopped your grandparents from meeting, you wouldn't erase yourself from existence. Instead, you would simply create a new timeline, a new branch of reality where you were never born. You, the time traveler, would still exist, but you'd be stuck in a universe that isn't your own. It solves the paradox but raises a new question. Could you ever get back home? Fifth on our list is the concept of wormholes. Officially known as Einstein-Rosen bridges, these are theoretical tunnels through space-time that could, in principle, connect to distant points in space, or even to different points in time. Think of it like folding a piece of paper in half and poking a pencil through it. Instead of traveling across the whole sheet, you take a shortcut. While mathematically possible, we have no more evidence that wormholes exist, and even if they did, keeping one stable enough for travel would require a type of exotic matter with negative energy, something we haven't discovered yet. Let's move to fact number 6. The speed of light is the ultimate cosmic speed limit. According to Einstein, nothing with mass can ever reach the speed of light, let alone surpass it. Why is this important for time travel? Some theories suggest that if you could break this barrier, you could potentially move backward in time. It's a popular idea in sci-fi. But as far as our current understanding of physics goes, it's firmly in the realm of fantasy. Accelerating an object with mass to that speed would require an infinite amount of energy. Our seventh mind-bending fact is the Novikov self-consistency principle. Proposed by physicist Igor Novikov, this principle offers another way out of paradoxes. It basically states that if an event exists that would cause a paradox, then the probability of that event occurring is zero. In simpler terms, the universe has a built-in self-preservation system. So, if you traveled back in time to stop yourself from being born, the laws of physics would conspire to make you fail. Your gun would jam, you'd slip on a banana peel, or a bird would distract you at the crucial moment. Essentially, you can't change the past because the past has already happened, and you were part of it all along. Fact number 8 delves into a fascinating theoretical particle, the tachyon. Tachyons are hypothetical particles that always travel faster than light. Because of this, they would appear to move backward in time. If tachyons existed and we could harness them to send signals, we could essentially send messages to the past. This would be a form of information time travel. Imagine sending winning lottery numbers back to your younger self. However, like wormholes, tachyons are purely theoretical. Many physicists believe they can't exist because they would violate causality, the principle that a cause must always precede its effect. Ninth, we have cosmic strings. These are not that highly speculative but fascinating concept. Cosmic strings are thought to be infinitesimally thin but incredibly dense defects in the fabric of spacetime, leftovers from the early universe. Some theories propose that if you could find two of these strings moving past each other at high speed, the warped spacetime around them might create what's called a closed time-like curve. Following this path could, in theory, loop you back to your starting point in space-time, effectively allowing you to travel to the past. But again, finding these strings, let alone manipulating them, is a monumental, perhaps impossible, task. Finally, our 10th fact is a bit of a reality check. One of the strongest arguments against the existence of backward time travel is the Fermi paradox, but applied to time. It asks, if time travel to the past is possible, where are all the tourists from the future? You'd think our time would be a popular destination for historians, researchers, or just curious sightseers. The fact that we haven't been inundated with visitors from tomorrow suggests that either time travel to the past is impossible, it's incredibly difficult and rare, or perhaps future civilizations have a strict no-interference policy like Star Trek's Prime Directive to protect the timeline. Or maybe, just maybe, they're here already, hidden in plain sight, carefully observing us. So, while hopping in a time machine might remain a dream for now, the science behind it is a wild ride through the most fundamental principles of our universe. From time dilation and the black holes to paradoxes and the parallel worlds, the study of time travel pushes the boundaries of our imagination and our understanding of reality itself. Who knows what future discoveries will reveal? Thanks so much for joining us on this journey through space-time. If you enjoyed this video and you want to explore more mind-bending science, be sure to hit that like button, subscribe to the channel, and ring the notification bell so you never miss an update. What are your thoughts on time travel? Let us know in the comments below. Until next time, keep looking up.